National Electrical Code Article 408.15 states where more than one disconnecting means is provided for the same equipment, each disconnecting means shall be capable of disconnecting the entire equipment. Each such disconnecting means shall be marked to indicate its purpose. Article 408.15b4 states where more than one disconnect is provided for the control of a given equipment, the location of each disconnect shall be identified. The National Electrical Code does not specify a minimum or maximum distance between multiple main disconnects for an MCC center. However, the location of each disconnect must be clearly marked to indicate its purpose, and the disconnects must be capable of interrupting the entire load. Concerns may arise regarding safety, as having two main disconnects in close proximity could create confusion or increase the risk of an accident. However, the National Electrical Code does not specifically address this concern. While the National Electrical Code does not impose a specific distance requirement, it is generally considered good practice to maintain a reasonable distance between multiple disconnects to firstly ensure clear and easy access to each disconnect, secondly minimize the potential for accidental operation, and thirdly improve safety for maintenance personnel. It is essential to consult the latest edition of the National Electrical Code and any applicable local codes or regulations for the most accurate and up-to-date requirements. The intent of the code is to ensure electrical safety, and proper installation practices are crucial. Always prioritize safety when working with electrical equipment. Consider consulting with a qualified electrical engineer or inspector for specific guidance on your project. The National Electrical Code serves as a comprehensive guide for electrical installations, but it's not a substitute for professional judgment and expertise. When dealing with motor control centers, or MCCs, and their associated disconnects, several factors must be considered to ensure safe and compliant installation. These include the interrupting capacity of the disconnects, the proper labeling and identification of each disconnect, and adherence to all applicable codes and standards. The design and installation of an MCC should always be performed by qualified professionals who are familiar with the National Electrical Code and best practices for electrical safety. An MCC is a central assembly of motor starters, feeders, and control devices, typically housed in a metal enclosure. It provides a convenient and organized way to control and protect multiple motors and other electrical loads. The main disconnects in an MCC serve to isolate the entire assembly from the incoming power supply, allowing for safe maintenance and repair work. When multiple disconnects are used, it's crucial to ensure that each disconnect is properly sized and rated for the load it is intended to serve. The interrupting capacity of the disconnects must be sufficient to safely interrupt the maximum available fault current at that point in the electrical system. This is typically determined by performing a short-circuit study of the electrical system. The National Electrical Code requires that all electrical equipment be clearly labeled and identified. This is especially important for MCC with multiple disconnects. Each disconnect should be labeled to indicate its purpose and the equipment it controls. This helps to prevent confusion and ensures that the correct disconnect is opened when performing maintenance or troubleshooting. In addition to the National Electrical Code, there may be other applicable codes and standards that must be followed when installing an MCC. These may include local building codes, as well as industry standards such as those published by the National Electrical Manufacturers Association, or NEMA. It's important to be aware of all applicable requirements and to ensure that the installation is compliant. Regular maintenance is essential for ensuring the safe and reliable operation of an MCC. This includes inspecting the disconnects for any signs of damage or wear, tightening all connections, and testing the operation of the disconnects to ensure that they are functioning properly. Any problems that are identified during maintenance should be addressed promptly to prevent potential safety hazards. In addition to the physical aspects of the MCC and its disconnects, it's also important to consider the electrical system that feeds the MCC. The incoming power supply must be properly sized and protected to prevent overloads and short circuits. The grounding system must also be properly installed to provide a low impedance path for fault currents. The National Electrical Code contains detailed requirements for electrical system grounding. When working on or near an MCC, it's essential to follow all applicable safety precautions. This includes wearing appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and arc flash-rated clothing. It's also important to de-energize the MCC before performing any work on the internal components. Lockout-tagout procedures should be followed to prevent accidental re-energization of the equipment. The presence of multiple disconnects in an MCC can sometimes create confusion or increase the risk of accidents. For example, if two disconnects are located very close to each other, it may be difficult to quickly identify the correct disconnect in an emergency situation. This could lead to delays in shutting down the equipment, which could potentially exacerbate the problem. In some cases, it may be possible to consolidate multiple disconnects into a single disconnect. This can simplify the system and reduce the risk of confusion. However, it's important to ensure that the single disconnect is properly sized and rated for the entire load. It's also important to consider the potential impact on system reliability. If the single disconnect fails, the entire MCC will be shut down. In other cases, it may be necessary to maintain multiple disconnects for functional reasons. For example, if the MCC feeds multiple critical loads, it may be desirable to have separate disconnects for each load. This allows for selective disconnection of individual loads without affecting the others. In these situations, it's especially important to ensure that the disconnects are clearly labeled and identified. It's also important to train personnel on the proper operation of the disconnects. Regular drills can help to ensure that personnel are familiar with the location and operation of the disconnects and that they can quickly respond to emergencies. The design and installation of an MCC with multiple disconnects can be complex. It's important to work with qualified professionals who have experience in this area. A qualified electrical engineer can help to ensure that the system is properly designed and that it meets all applicable codes and standards. A qualified electrical contractor can ensure that the system is properly installed and that it is safe and reliable. The National Electrical Code is constantly evolving to reflect changes in technology and best practices. It's important to stay up to date on the latest requirements. This can be done by attending training courses, reading industry publications, and consulting with qualified professionals. By following the National Electrical Code and best practices for electrical safety, you can help to ensure the safe and reliable operation of your MCC and other electrical equipment. Remember to always prioritize safety when working with electrical equipment. If you are not qualified to perform the work, seek assistance from a qualified professional. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified professionals before making any decisions about electrical installations. The presence of two main disconnects within 8 feet of each other for a 480-volt motor control center raises concerns regarding clarity and safety, even though the National Electrical Code does not explicitly specify a minimum or maximum distance. While code compliance is paramount, practical considerations play a significant role in ensuring a safe and efficient electrical system. Firstly, consider the potential for confusion. In an emergency situation, quick and decisive action is crucial. If two disconnects are located in close proximity, personnel may inadvertently operate the wrong disconnect, leading to unintended consequences. Clear and unambiguous labeling is essential. Each disconnect must be prominently marked with a durable label that clearly identifies the equipment it serves. The labels should be large enough to be easily read from a distance, and they should be resistant to fading or damage from environmental factors. Secondly, accessibility is a key factor. The disconnects must be readily accessible for operation and maintenance. Obstructions should be removed to ensure that personnel can easily reach and operate the disconnects without difficulty. Sufficient clearance should be provided around the disconnects to allow for safe working space. Thirdly, safety is always the top priority. When working on or near electrical equipment, it's essential to follow all applicable safety procedures. This includes wearing appropriate personal protective equipment such as safety glasses, gloves, and arc flash-rated clothing. The equipment should be de-energized and locked out tagout before any work is performed. The National Electrical Code provides detailed requirements for electrical safety. It's important to be familiar with these requirements and to follow them carefully. The NEC Article 110.26 addresses spaces about electrical equipment, specifying working space, access, and entrance to working space to allow safe operation and maintenance of electrical equipment. While this section doesn't dictate distances between disconnects, it underscores the importance of adequate space for personnel to perform tasks safely. Consider the type of equipment being served by the MCC. If the MCC controls critical loads, it may be desirable to have redundant disconnects to ensure that the equipment can be quickly shut down in an emergency. In this case, it's especially important to ensure that the disconnects are clearly labeled and that personnel are trained on their proper operation. The overall layout of the electrical room or area should also be considered. The disconnect should be located in a logical and easily accessible location. The area should be well lit and free of obstructions. The disconnect should be protected from damage from environmental factors such as moisture, dust, and vibration. In addition to the National Electrical Code, there may be other applicable codes and standards that must be followed. These may include local building codes, as well as industry standards such as those published by the National Electrical Manufacturers Association or NEMA, and the Institute of Electrical and Electronics Engineers or IEE. It's important to be aware of all applicable requirements and to ensure that the installation is compliant. Regular inspection should be performed to ensure that the disconnects are in good working order and that they are properly labeled. Any problems that are identified should be addressed promptly to prevent potential safety hazards. The use of multiple disconnects can be a complex issue. It's important to carefully consider all of the relevant factors before making a decision. The National Electrical Code provides guidance on many aspects of electrical installations, but it's not a substitute for professional judgment. If you have any questions or concerns, consult with a qualified electrical engineer or inspector. The primary concern is to mitigate any potential safety hazards. While there is no hard and fast rule regarding the distance between disconnects, the overriding principle is to ensure the safety of personnel and the reliable operation of the electrical system. A risk assessment should be conducted to evaluate the potential hazards associated with the close proximity of the disconnects. This assessment should consider factors such as the likelihood of accidental operation, the potential for confusion in an emergency, and the accessibility of the disconnects for maintenance and repair. Based on the results of the risk assessment, appropriate mitigation measures should be implemented. These measures may include installing barriers to prevent accidental operation, providing additional lighting to improve visibility, or relocating one of the disconnects to a more suitable location. The focus is on achieving a balance between code compliance and practical safety considerations. The general foreman's concern highlights the importance of considering the human element in electrical system design. Even if an installation meets the minimum requirements of the National Electrical Code, it may not be the safest or most efficient design. By taking a proactive approach to safety and carefully considering the needs of personnel, it's possible to create an electrical system that is both compliant and user-friendly.